So I did a little bit of an audible. If you were reading close in the emails that went out, uh, I decided to make a couple little changes in the presentation. I've done many of these presentations over the period of time. In my background, I was one of the past owners of Tannis Aircraft Products. Currently own a company called Dover Aviation, which was the holding company of Tannis. Tannis is now owned by Signia Hartzell Group, and they also own several other HET, Hartzell Propeller, Rife, and the preheating side. So I'm going to go through the various types of preheating and the pros and cons of each of those types and the information that I gathered prior to owning Tannis, while owning Tannis, and now the 4 years since I've sold the company and finding the information out and trying to convey that to you. I'm going to try to leave a fair amount of time at the end. This webinar is recorded, and I am going to make it available. Laura and the team there will make it available for you to look at. So things that are covered in the webinar, you can always go back to and gather that information. But I have found that many times some of the questions that come from the participants are things that I may not have covered yet in a presentation. And that just makes my presentation better as we move forward. I will include those. So this is a snapshot, basically all the various types of preheating, and we'll get into those. First, what is preheating? What is preheating weather? When should I start preheating? Some things are no-brainers. When you see a minus 33 degree Fahrenheit morning, you know that that's preheating weather. Or if you had to take your dog sled out to the hangar to get your airplane up, that's probably preheat weather. And the wonderful thing in Minnesota called Iceport, the first weekend in March, almost every year we have something called Iceport, and Tannis has been a part of that since its inception many years ago, probably now 11, 12, 13 years ago. And now Hartzell, being the owner of Tannis, is still continuing to that. But that's definitely preheat weather, and they land literally over 100 in some airplanes if the weather is good. So I'm going to start right in the beginning and say, when should I start preheating? Because that's a question that we get most often. And I'm going to give you a couple, I call it boilerplate answers to start with, and then we're going to dig in deeper as we determine why we preheat and how we preheat. Basically, whenever your aircraft sees something less than minus 50, or excuse me, something less than 50 degrees Fahrenheit, then you will gain benefit from preheating. And almost all engine manufacturers require preheating when the engine itself is equal to or below 20 degrees Fahrenheit. When I was at Tannis, we determined that there's even benefits below 60 in your aircraft for preheating. These are things that I've stated almost in every presentation. What are our main goals of preheating? We want to reduce engine wear. It isn't really starting the engine. It isn't, hey, I can't get that aircraft engine started. We want to reduce the engine wear because of the dissimilar metals that expand at different rates. And if it's 20 degrees, the aluminum is a whole lot smaller than something that's steel or brass, and they do not have oil being pumped through them yet. And that's really the key issue, is reduce that engine wear, increase the engine life so we can get to our TBO or beyond it. Many of the aircraft that we fly have a battery forward of the firewall in the same place that we're preheating. So when you preheat, getting that battery warm is really an advantage. And there are also battery elements that you can put on it if your battery is after the firewall. Yes, getting it started, the ease of starting is important. Frosting the spark plugs is a killer, can really screw up your day when you make a little bit of a mistake and can't get it started right away. And then you're going to be sitting down for a while. And even in the middle of summer, we've found out. I had the opportunity last weekend to be at the Fagan's Museum in Granite Falls, Minnesota, with all of the warbirds, the radial engines have to have oil temp at a certain temp before they can fly. Well, we can preheat those oil reservoirs to get them up to temperature quicker. Preventing that cylinder scoring because we know most of our cylinders are tapered tighter up in top than they are in the bottom. We want to get oil flow as quickly as possible. And something beyond the engine, we want to get that proper oil flow and we want to warm up all critical driveline components that have some type of liquid or oil or grease in them because they're all affected very, very quickly of that cold temperature outside. Increasing safety, and as we stated earlier, there are engine manufacturers that say at a particular temperature you must preheat. That is a mandate. So, switching the gears to what type of preheat systems are out there. My favorite one and the most expensive one is a heated hanger. If you have a heated hanger, keeping that hanger at 60 degrees is a wonderful thing. And it would be great to have that, but I've found that they're very hard to take with you on various flights. I will talk about that more in the presentation. The heated forced air, and I just done some Google searches and also for my time of owning Tanis, put down manufacturers that I know that play in certain areas. The Herman Nelson, Aerotherm, aircraftheaters.com makes a forced air type of preheat system. The only two multi-point preheat systems that I know that exist is Tanis and Rife. And then there are a sump type or a only heating the oil type of preheat system. So let's talk about the pros and cons of each one. Having a nice hanger like this with heat and also air conditioning, if you can, is a wonderful thing. But you see this little item right over here that I'm drawing a circle around. That's the LP tank. And this is a hangar in Glenwood, Minnesota. That little LP tank will have to be filled every month when it's normal Minnesota weather. And yes, it takes about $1,000 currently to fill that up. So disadvantage, of course, is the cost. One thing, if you are in the thought process of having a heated hangar, in-floor heat is the way to go. Having that heat on the bottom because we know how big these hangars are and all that air volume, and trying to heat up all the air is a costly maneuver. And when you open the door, it's all gone. Having an in-floor heat system when you're going to spend that type of money is the thing and the way to go because anything that drips off the plane that you may, not that we want to carry ice on the plane, but when it does, it evaporates right away. And when you're working on the airplane, as soon as you close the door, that floor is warm and you can move forward. Then into the talking about the forced air, blowing hot air into your aircraft engine type. And I'm going to show you a couple of them here. The advantage of those is, other than the Herman Nelson, they're not permanently fixed. Obviously, the Herman Nelson isn't affixed to your aircraft either, but you're not going to carry that with you. Where a couple of the other ones I'm going to be showing you next, you couldn't put in your aircraft and carry with you, but it's not mounted on the aircraft. And some people want to keep them, especially if you have a non-electric airplane and flying in areas where you're hand propping it to start it. Blowing hot air is a way to get some means of preheating to it, and the biggest advantage is it's not permanently mounted, but also the disadvantage is with the Herman Nelson and other open flame. This is an indirect. Most of the good ones now are indirect type of heat, but there's many that have an open flame and it gets really hot and you have to be very careful not to overheat it when you have something this big. But if you move to Aerotherm and the aircraftheaters.com, a much smaller one that you're plugging in, and the pro of that again is it's put it in a bag, carry it with you when you want to. It's not, you don't have to install it, don't need to have a mechanic install it on your aircraft. But these next two types, really take a tremendously long time to heat the aircraft engine. And what it does is it kind of gives you a false sense of security because, it's blowing that warm air into the aircraft. And you put your hand inside the aircraft cowling and touch the engine, and you're like, wow, it's warm. You may even see some CHD temps come up. But if you take a look at your oil temp, it will take hours and hours and hours for that to do. Many of them, day to get it up to the right temperature because you only are going to have 15 or 20 amp circuit to run these, and they're anywhere from 100 to 1,000 watts of power, and so much of it's going to leak out and blow away when you're circulating it inside of your cowl. So that's the con part of it. But again, I've talked about the pro. This one is one that you just put inside the cowl opening, but as you see, it's only about 100 to 250 watts of power. You would have to plug up the cowl openings and have a very good uh, engine cover blanket, and you'd have to preheat for a long, long time to get any amount of oil temp rise. I'm talking 6, 12, 24 hours related to the airflow side. Now we'll move over to probably the most popular type of preheat systems is the multi-point preheat system. And when we say multi-point, basically what we're doing is we are heating the oil and the piston, the a lot of times the crankcase, the basically the whole engine. We're putting heats in various different places to try to heat that engine up as quickly as possible and uniformly, getting more heat than just oil or just blowing air around the side. And the good news about that is when you put your multi-point preheat system in, we don't have airflow affecting it as much. So this is the Tannis system, and the other system known out there is Rife, both currently owned by Signia Aerospace, Hartzell Aerospace, and the difference between the two is Tannis will take out a rocker cover or intake tube and replace that fastener with a heated bolt, and Rife takes and puts the band around the base of the cylinder. Uh, when I was with Tannis, you probably heard me say many, many times, heating from the inside out is so much more efficient than heating from the outside in. Those threaded elements going inside the jug, your cylinder jug, is so effective. Even the four-cylinder Tannis is 240 watts, but it'll heat that engine up in 2 hours, 2.5 hours in a normal condition. Where the Rife is going around the base of the cylinder. So it's going to take a little bit longer, and it doesn't get all the way up to the top of the cylinder because of the fact that that's an air-cooled, most of them are air-cooled cylinders, and that air will be bled off on there. So the advantage of these, they do a much better job of heating up the engine, much more efficient, and they do address both the crankcase, the oil in the crankcase, and the jugs, your cylinders, where the previous forced air doesn't. And the disadvantage is they have to be installed. And other than on an experimental, you would need to have this installed by an A&P in the United States, for instance, or a certified individual to be able to have this a logbook entry for your aircraft engine. I will state that the great thing about Tannis is you can leave it plugged in all the time because it gets everything above the oil line warmer than the oil. And we're going to talk about that a little bit later on in the presentation on why that's important and how leaving it plugged in has some advantages. The Rife system gets the cylinders uh, or gets the oil warmer than the cylinders, and we found that is a bit of an issue, as you'll see in some of the charts as we move forward. There are also then what I call sump only or oil only type preheat systems. This is an easy heat system where they're adhering an electrical resistance pad element to the bottom of the sump and heating up that sump, and then having that sump then warmed up and providing heat to the top of the aircraft engine. The issue there is you're always going to get the sump and the oil warmer than your cylinders. And when we start talking about the moisture that's inside your engine and dew point, you're going to see that that's an issue. So the pro on that is that's the most inexpensive method of an installed system, but it really should only be used a couple hours before you fly before flight, and then make sure you do fly when you have these because they're going to evaporate a lot of moisture that's in your sump and put it up into the upper part of your aircraft engine. Another type is Safe Heat, McFarland, another private equity firm owned company that fixes it to the sump. And then I found this one, I think a year or two ago. The uh, anti-splat arrow is a basically removes on some of the light combing where they have two oil plugs, your drain and also for remote oil pump. You can take that one, basically a brass element out and put this in. So now you're heating up the oil directly versus gluing something into it. Now, anything that's installed on a certified aircraft needs to have a sign off and has to be installed by a certified mechanic. Also, Rife makes a just you can buy just the sump side of their system. Tannis does not. Tannis will only sell you a complete system. So let's get into the physics and the information that you should consider as a pilot or as a mechanic when you're looking at preheating. And when I talked about moisture and with moisture is dew point, here is the physics side of it. Water evaporates at any temperature, even when it's 20 below zero out there, we're still got evaporation. The evaporation rate is the delta between the temperature of the water or the ice and the ambient surrounding temperature. So when we start preheating, we actually increase that evaporation, or whenever the heat around your ambient of the aircraft, it will cause that moisture to evaporate. And with aircraft engine, and when we think about moisture, while we're running the engine, there's blow by and there's a lot of moisture that gets pushed into our sump. And when we shut that aircraft engine off, that aircraft engine, most of them are going to be 180-degree oil. So the sump's going to be somewhere in that range. And if you took a reading of relative humidity, it's going to be darn close to 100%, 90+% relative humidity. A lot of moisture content that then condenses, drops in the oil. It's heavier than the oil. It drops to the bottom of your sump. Then when you park your aircraft away, it starts reversing. It will start evaporating and come out of that. And these are the important points to remember when we think about the type of preheat system that we are using and how we use it. And I'll get into some graphs that we put together when I was at Tannis, and also how can you as a pilot determine, is my oil warmer than my cylinders, and am I getting a adequate job of preheating? If you have an aircraft that has any type of engine monitoring devices, such as the Cirrus or uh, a monitor like this, you can look right away and you can get your temperature readings from this instrumentation. You can tell what your CHTs are, your oil temperature. Now, I will give you a caveat there. Some oil sensors are not necessarily in the sump. They might be in line with the oil pump, but you're very quickly going to get a temperature reading either before you start up the engine or once you start it up. But that can give you that feedback. Hey, is my Tannis working? Is my Rife working? How well is it working? Is my sump system working? What am I seeing when I snap on that information? Or you can do what Tanis did, we took certified uh, calibrated data loggers and took temperature readings of all the various points that we considered to be important when it comes to preheating. So here's a case of a four-cylinder engine that we taped thermocouples on the opposite side of where Tanis has their heated bolt, or when we did the Rife system, away from that band. So we're not picking up heat from the actual heater, but we're measuring the cylinder temperature, pushing something into the oil so that we can read that. And then we gather all that information and plot it out. So at the time when I owned Tanis, we determined how we need to manufacture and engineer our systems and then testing them to see how well they're working or are they meeting the requirements we have. And then we get a chart, something like this. And the key part that if you remember nothing else is remember this. When you're preheating, you want, these are my four cylinders. I want this delta, the difference between my cylinder temperature and the green here is my oil temperature. I want those two temperatures to be different because the dew point inside the engine will almost always be the temperature of your oil because that is the biggest mass inside that sump. And as long as the metal items above the oil line or above dew point or warmer than dew point, you will never get condensation. You will not have moisture adhere to that. And then that eliminates the possibility of that whole corrosion activity starting. So that's key. That sump that tells us that this Tanis system inside of 2 hours, we've got it up to temp 50 to 60 degrees above ambient. The ambient temperature is the bottom line right here. Very important to know. What happens? This is, I just to show folks, Tanis does not have a thermostat. Where the Rife, you can install a thermostat, and you will see in my do's and don'ts at the end here. I don't recommend that. Once you turn them on, and then you fly. And the reason why Tanis can do that, they design their system with just the amount of wattage to get the cylinder temperatures where they want it and the oil temperature where they want it. And when the ambient temperature goes up or down, you'll see how that also makes a difference in the cylinder temperatures and even the oil temperatures over the period of time. This also happened to be one where we're using a cabin heater, so don't let that one fall you. This is the oil temperature right here. Uh, Sometimes when you're in certain parts or certain climates, certain parts of the world or certain climates, you need more than that 50 to 60 degree ambient temperature rise. Then you will need to have a insulated engine cover or some means of containing that heat inside your cowling. And this gives you, for a Tanis user, information to say, I got my 50 to 60 degrees above ambient here, but hey, it's minus 20 degrees Fahrenheit. I need more. Then you need to use a cover, and then you're going to see it's going to have a longer period of time, an overnight preheat to get that temperature into the range that I want to see it before I take off. This was an interesting item that we were working with a flight school, and they went and put Tanis on all of their aircraft engines, and we were doing some data logging, and came back the next day, and I saw this data, and I was like, what the heck is happening here when I see the CHT temperatures bouncing around so much? Well, at this time at night, so at 7 p.m., they stopped flying and they closed the hangar door. These were aircrafts that were parked inside of a very large hangar. Once we close the hangar door, what changes? No more wind blowing around and no more air blowing in and out of my cowl openings. So this became a Tanis marketing item to say the use of cowl plugs is very important. That little difference right there is just ambient air blowing in and out of your cowl opening. So using an insulated cover or putting in cowl plugs makes a huge difference. This was a customer that was using a sump only preheat system. And they said, well, we use a insulated engine cover. So eventually everything is going to get the same temperature as the oil. It's great in thought and theory, but it's not in fact, because here is the temperature of my cylinders and here's my oil temperature. And what did I say earlier? That means my moisture is evaporating out of the oil. And if the dew point is 80 some degrees, 70 to 80 degrees, and I've got 40 to 50 degree cylinders, that moisture is now going to collect on the first the rocker cover, then the valves, the top of my piston, and just make its way down. So important thing to remember if you're using a sump only. And that's why we stated if you're going to use a sump only, if you have no other, you bought the airplane and that's what's in there, and that's really what you're going to live with for a period of time, just use it prior to flight so that you get the oil warmed up so that it starts to flow throughout the engine uh, quicker, but make sure you only use it for that couple hours prior to flight. We took that aircraft engine, replaced it with the Tannis, and now you see here's the oil temp, here are the cylinder temps. Really makes a big difference. And you'll also see when we talk about insulated engine covers, Tannis started measuring the temperature of props, especially if you have an aluminum prop. It's connected directly to your crankshaft. And yes, that dissipates heat. And most of the time, at least 5 to 10 degrees warmer than the oil or than the ambient, so that it's important if you are in really cold temperatures that you think about not only that cowl blanket, but also some type of prop covers. So let's talk about moisture. Dew point, dew point, dew point. You've heard me say it so many times. Here are dew point sensors. And I'm going to show you a slide in just a little bit. Think dew point, do not think relative humidity, because relative humidity is what? What's that first word? Relative. It's dependent on the temperature. Warmer temperature can hold a lot more moisture. So the percentage drops down when you warm up. But here is an example of where we're measuring the dew point. So we took a dew point sensor, dropped it in the oil fill just above the oil line, and measured the dew point of this aircraft engine over time. And then plugged in the Tannis, and you see that normally this particular time we had a good delta between oil temperature and air temperature, cylinder temperature. But during that plug-in of the preheat time, we gained another 30 degrees. So that guarantees us that there's no moisture coming on that cylinder. And we've had many people that say, well, I'm going to do a test, and they go and put a relative humidity sensor, an RH, the things that you can buy locally, and they start out at 5 degrees C, and they look and they say, wow, hey, I have, it's 5 degrees C. My relative humidity is this line right here. And if I follow it up, that's 70%. So now I stuck on my sump only preheat system, and I warmed up that aircraft engine. And now my aircraft, the temperature reading I have is, 46 degrees, and my relative humidity is only 8%. So look at all the moisture that I got rid of, when in fact you did nothing. This is a psychrometric chart. That's just the difference of how much more water can be contained when the air temperature is 47 degrees versus 5 degrees, or even 20 degrees when we're in here. So point of that is do not use your relative humidity sensor. So what can you do if you don't have a preheat system and you're still concerned about it? Because there are many people that live in areas where they probably never or very rarely see 50 degrees Fahrenheit. Looking out at the system, and we actually worked with RPX on this, probably one of the better dehydrator systems on the market right now is this DryBot. It takes and just basically pumps in dry air either into your oil fill tube or your breather. Easiest is the oil fill tube, and it just bathes that aircraft engine with dry air, and then has its own recharging or reconditioning of the desiccant. It's basically a desiccant system trapping the moisture and just blowing very dry air inside the aircraft engine. great for keeping your aircraft engine dry, and that's important even when it's not wintertime flying. There are a couple other items in the marketplace that just again blow dry air into it. This is just taking a jar of desiccant and you're pulling the air through that desiccant and blowing it into your engine. Now you would have to take and regenerate that desiccant yourself every time. This one, and I don't know if it's still available, but over a period of time it was. It uses Peltier little plate to trap moisture. Basically, it's a mini air conditioner. A Peltier plate is something that pulls moisture. It goes on and then it will heat up. Uh, Takes a long time, and it really, if you have a really moist area, that's a tough one. But those two systems are the two systems really that we have found are probably the most effective when it comes to keeping dry air inside your aircraft engine. Uh, One other thing that people talk about. So, you heard me in a earlier part of this presentation say, leave it on overnight or a longer period of time, or just only use this a couple of hours before you fly. Well, if you live 40, 50 miles away from where your airplane is parked, that can be an issue. Uh, if you have internet at your aircraft, well, at your aircraft hangar, great, because then you can find a Wi-Fi plug and snap it on via your phone prior to use. But many, many hangars do not have even the capability of getting wired internet to them, or it's could be prohibitive, or the cost is even prohibitive, 50, 75, $100 a month. This is a system that's been out for a pretty large period of time now, a little, I think it's 2021, 2020, I think, when it came out. It basically has its own little 4G cellular device inside of it, and you can use an app on your phone to turn on your preheat system. So if you had a sump only, you heard me say, hey, may only turn that on a couple hours prior to flight. Well, if you're not going to be at your aircraft, 4 hours, 3 hours, 2 hours before flight, snap it on, and then you can go out there and then fly. If you have a Rife or a Tannis, turn it on the night before or turn it on depending on what your ambient temperature is, 2 3 hours before flight, and you can turn that system on and it'll give you feedback whether it's on. It can tell you the ambient temperature of where that device is located. So it's one of the items that I recommend, that if you don't want to leave your system on all the time, or you are located in a municipality that will not allow you to leave it on all the time, there is an option for you to go down that route of being able to turn your system on remotely. So, getting to the conclusion side here, uh, just a summary of things that I call the do's and don'ts of preheating. Everything we said here was things that uh, Dover Aviation, Tannis Aircraft, or other folks have tested and found, and that's their information. But we must always remember the gospel is the gospel per your POH. Always check your pilot operating handbook on what it talks about for preheating and what are some of their recommendations. What we have found is Lycoming Continental have stated that whenever that engine temp itself is 20 degrees Fahrenheit or less, you must preheat. They know that there's concerns if you preheat. If you do not preheat and that engine is 10 degrees Fahrenheit and you start it up, you are starting to deal with some issues there. Do not use a timer. We've had many people that say, wow, what I do is I put it on a timer and 6 o'clock in the morning, it comes on because I'm going to fly in the morning. And then if I haven't flown at 10 o'clock, it turns it off. You don't want to do that because no matter what type of system you're using, even the Tannis, your biggest mass in that aircraft, other than your whole crankcase or your crankcase, is that, in fact, even the oil. If you got 8 quarts of oil, You got 60, 70 pounds of mass there that once you heat it up, it's warm, and now you turn it off. The last thing to cool down is that oil sump. First thing to cool down is your cylinders. So your cylinder now drops below dew point, and you're taking and condensing that moisture onto the surface of your cylinder walls, piston valve, cams, especially. The other side that we've seen many times is people using a thermostat. They say, well, when I've got a thermostat in there, whenever it gets below 50, it turns my preheat system on. Then it gets above 50, it turns it off. Let's take a scenario in Minneapolis. I guess sounds like Sunday night will be our first night in a while that it drops below 50 degrees again. And the, that would, with the thermostat, it would turn it on. But then during the day, Sunday, it's going to get up to 65. Well, now I'm going to turn it off. Well, the minute I do that, I've got my oil sump warmed up again. And once I turn it off, then my cylinders drop below dew point and I run across that problem of condensation. Once you've preheated and once you've started preheating, my advice is do not stop until you fly the aircraft. The only caveat is if you turn it on your sump only, just a couple hours before flight time, like I had stated, and then all of a sudden you get fogged in or weather comes in or you're not IFR capable and you're socked in with weather, then don't leave it on necessarily that whole time because now you're just going to keep on evaporating more and more and more moisture. When you turn it off, it's still going to put condensation onto your cylinders, but it'll stop until you fly. But then make a note to yourself, make sure you fly. The most important thing is fly your aircraft regularly. And if you don't, consider a method to remove that moisture from the inside of your engine, either using a dehydrator type system, or I know Tanis has a kit that you can buy, and Lycoming and Continental have means of saying, hey, here's a way to store your engine, or you drop the oil, you're putting in different oil and basically fogging the engine, spraying the cylinders, putting desiccant, replacing your spark plugs with some desiccant plugs, putting desiccant inside your exhaust, drying off that engine to store that over a period of time. And one thing that I don't put in print, because I don't want to be a person that says, they only read part of it and didn't hear the caveat. When you're done flying, if you open up your oil fill cap and leave that off for a period of time, you will see tons of moisture leave your aircraft engine. So I recommend that. But if you do it, make sure you take and put a flag on it, or take the key and put a flag on it, or do something so that you know that that oil fill cap is not on, because yes, people have started up and started flying only to have their windscreen full of oil, and there's a liability part there. So we've done tests on it, and boy, you can get rid of a lot of the moisture if you're looking at moisture content. One of the tests that I did is, doing that, we saw over 50% of the moisture leave the engine during that period of time. So again, it also tells you if you start moving air through that aircraft engine after you're done flying, you get rid of that moisture. And last but not least, do not overheat if you have one of those large forced air systems. You're someplace where you're normally warm, where you're flying, and you fly to go skiing in Colorado or Stowe, Vermont, or wherever it's at, and you're like, oh, I need to get some preheat, so I'll call up the FBO. They come out with their Herman Nelson and they're pouring heat to it. They can get a lot of heat in a short period of time. So beware of that. So I will start opening it up to questions, but before I do that, and while Laura gets all of those questions in here, these are just to tease Laura because she tends to like to be in Alaska as much as I do and fly over there. So, I've found means of parts of Alaska. It's really important to have a hot tub on your deck when you're at the Airbnb, or, if you're going to go start climbing or snowshoeing in areas, they have places to do it. But again, I recommend to have a place where you can have soup and then maybe adult beverage off to the side when you're done hiking. take a helicopter, fly someplace, and you get to see the blue water on glaciers and enjoy the scenery of the Alaska area. You see earlier on, you see my infinity to sled dogs. I love spending time with sled dogs. It's an amazing animal that folks use. The Iditarod is an amazing thing to follow or get involved with over there. And yeah, hey, if you want to go fishing, they have that also. And if you ever get to Anchorage, there is the world's largest float plane base there with Lake Hood. Stop at Lakefront Hotel and have a bite to eat, and you can watch the seaplanes take off from just the minute that ice leaves that lake to when it freezes over. That is their means of getting to remote areas of Alaska. So I'll leave this up for just a little bit and then left 15 minutes, 20 minutes for questions. And as I stated earlier, this is being recorded and it will be available on their YouTube. So if there are questions that are addressed in the presentation, I'll say they're there and you can go back and look at them. If they're new questions, then I'll try to respond to them. And Laura and I already talked. If we know there's not going to be time to answer all questions, she's going to email me that question database. And you may have heard I've sold the company, and yes, I'm mostly retired, so I have a little bit more time on my hands, and I will respond to those over a period of time. But that is my contact information if you want to get a hold of me, Doug at doveraviation.com, and that is my cell phone number that you can use.